In parasitology, correct specimen collection and handling are critical for accurate diagnosis. General guidelines recommend examining 3 stool specimens within a 10-day span, ideally every other day to increase detection rates. Liquid specimens should be examined within 30 minutes of passage or placed immediately into preservative. Soft specimens should be examined within 1 hour or preserved, while formed stools may be examined within 24 hours. An aliquot should always be placed in preservative, with the remainder refrigerated. For fecal specimens, collection must be done in a clean, dry container with a secure lid. Specimens contaminated with urine, water, or barium oil enemas are not acceptable. Urine can destroy motile organisms. Water may introduce free-living organisms, and barium can mask intestinal protozoa for up to 5 to 10 days after administration. Additionally, antibiotics alter intestinal flora, and parasite recovery may not be possible until 2 weeks after the last dose. Other specimens also play an important role. Sputum should be collected in the early morning when it is most concentrated. Cerebrospinal fluid must not be diluted. Urine is best when collected as the first void or early morning sample. Genital specimens should be collected using saline-moistened swabs. Tissue and skin specimens should be placed in sterile containers to prevent contamination. For blood specimens, both thick and thin smears are prepared. The thick smear allows for concentration and easier detection of parasites, while the thin smear provides the necessary morphology for species identification. Examination of stool specimens for ova, cysts, and parasites involves several steps: macroscopic inspection, microscopic examination, permanent smears, and wet mounts. Macroscopic examination evaluates consistency, presence of visible material, and color. Liquid specimens often contain trophozoites. Soft specimens may contain trophozoites and cysts, and formed stools are more likely to contain protozoan cysts or helminth eggs. The presence of mucus, blood, or visible parasites should be noted. Stool color can be informative. Black may indicate blood or iron, while light tan or white can suggest barium or absence of bile. Microscopic examination may reveal a variety of findings, including parasites, red blood cells, white blood cells such as eosinophils, Charcot-Leyden crystals, or even fungi like Candida species. Permanent smears are essential for diagnosis. The trichrome stain is the most commonly used and easy to perform. Wrights and Giemsa stains are used for blood smears. Acid-fast stains detect organisms like Cryptosporidium, Isospora, and Cyclospora. Modified trichrome stains are used for microsporidiosis. Iron hematoxylin stain enhances detection of microfilarial sheaths. Wet mounts are valuable for detecting motility. Saline preparations using 0.85% sodium chloride help visualize motile trophozoites under low light. Iodine kills trophozoites but enhances nuclear detail. Importantly, wet mounts are not performed on preserved specimens. In parasitology, proper preservation methods, concentration techniques, and understanding modes of transmission are essential for accurate diagnosis and prevention. Preservation methods include refrigeration, which is suitable for eggs, larvae, and amoebic cysts, but not for trophozoites. 10% formalin is also effective for eggs, larvae, and cysts. MIF, or merthiolate iodine formalin, works both as a preservative and for concentration, useful for eggs, larvae, and cysts. PVA, or polyvinyl alcohol, is considered the best for preserving amoebic trophozoites and allows permanent staining. SAF, or sodium acetate acetic acid formalin, is also effective for trophozoites and is safer environmentally compared to PVA and MIF. Schoutens fluid is specifically used for fresh stool samples, preserving both trophozoites and cysts. Concentration techniques help detect small numbers of parasites. Formalin ethyl acetate sedimentation separates material into 4 layers: ethyl acetate, debris, and fat; formalin, and sediment containing parasites. Ethyl acetate removes fats, while formalin preserves organisms. This method is simple, detects all parasites, and allows indefinite storage, but it leaves more debris. The zinc sulfate flotation technique uses a solution with a specific gravity of 1.18. Parasites float while heavier debris sinks. This method produces cleaner preparations and is non-flammable, but it may miss larger eggs like schistosomes and operculated eggs such as Diphyllobothrium latum. Modes of transmission are varied. Ingestion occurs when eggs, cysts, or larvae are swallowed, for example with Ascaris, Paragonomus, Trichinella, or Giardia. Penetration occurs when larvae directly enter through the skin, as in strongyloids, hookworm, or schistosoma. Vectors inject parasites into blood or tissue. For example, mosquitoes transmit Plasmodium, Brugia, and Wuchereria. Reduvid bugs or tsetse flies transmit Trypanosoma, ticks transmit Babesia, and sandflies transmit Leishmania. Sexual transmission can occur with Trichomonas. Parasites such as Trypanosoma, Plasmodium, and Babesia can also be spread through blood transfusion.